Let me give you some more examples of proportionality. So the volume of a sphere is given by this, where r is the radius of the sphere. What happens if you double the radius of this sphere? So what's the relationship between v and r? So if you double the radius, it turns out that the volume will get increased by 2 cubed. So it will increase by 8 times. If you triple the radius, then the volume will get increased by 3 cubed. So it will increase by 27 times. So the relationship here is that the volume is proportional to the cube of the radius. So this is another example of proportionality. So now let's look at the pendulum. So here you've got a pendulum. The time it takes to do one swing is given by t, and g is the gravitational pull of the Earth or the Moon or whatever planet you're on, and L is the length of the string. Now, what's the relationship between the length of the string and the time it takes to do one swing? So t, the time it takes to do one swing, and the length of the string. If I double the length of the string, it would take longer to make one swing. Well, what's the relationship between the two? It turns out that if you double the length of the string, then the period, the time it takes to do one swing, gets increased by a weird amount. It gets increased by square root of 2. So that's roughly 1.4 something. If you triple the length of the string, then the time it takes to do one swing, the period, gets increased by a weird amount. It gets increased by the square root of 3. And there's a way to determine this, which I will show you in the future. The point here is that the time it takes to do one swing is proportional to the square root of the length of the string. So it's written like this. Let me give you another example. What happens if you double the strength of gravity? So if you change the planet that you're on, what's the relationship between the time it takes to do one swing and gravity? It turns out, and there's a way to determine this, which I will show you in the future. If you double the strength of the gravity, then the time it takes to do one swing should be faster. It will be times by square root of g. So if you triple gravity, and remember, I'm just telling you this, you don't know why, I will show you in the future. If you times this by 3, then the time will decrease. It will get it will be 1 over square root of, sorry, this should be a 2. Should be 2. And this, if you triple the strength of gravity, then it will be the square root of 3. So it would be faster because you're dividing by a number. So the relationship between the period, the time it takes to do one swing, is written like this: 1 over square root of g. So when you come to pronounce this, you would have to say that the time that it takes to do one swing is inversely proportional to the square root of gravity, and it's written like this. Okay?